The first two Fibonacci numbers are both 1, and then every number after that is the sum of the two previous numbers. So the first several Fibonacci numbers are 1, 1, 1 plus 1 is 2, 1 plus 2 is 3, 5, 8, 13, 21, 34, and so forth. So the Fibonacci numbers show up in many unexpected situations and have many beautiful properties. And we begin by presenting a motivating example. So consider a board of length n. How many ways are there to tile this board with squares that have length 1 and dominoes that have length 2? Well, we can let the number of tilings of an n board be little f of n, and we can calculate little f of 4. And we do this manually by just counting all the different possibilities. So we can see that we can have a tiling which is all squares, we can have a tiling which is 2 squares and a domino, a square, domino, square, domino and then 2 squares, or 2 dominoes. So in total, there's 5 possible tilings. But for larger values of n, we obviously can't do this manually, so we're going to need a different strategy. And to do that, we can break this into two cases. We can observe that if an n board begins with a square, then we have to tile an n-1 board. However, if the n board begins with a domino, then we have to tile an n-2 board. Therefore, the number of tilings of an n board is just the number of tilings of an n-1 board plus the number of tilings of an n-2 board. And we can also compute that little f of 1 is equal to 1, and little f of 2 is going to be two cases because it can either be 2 squares or 1 domino. Therefore, we can compute the next several values as little f of 3 is 3, little f of 4 is 5, which is what we found before, little f of 5 is equal to 8. Which should look very familiar to what we just saw with the Fibonacci sequence. And in fact, this is exactly the Fibonacci numbers, except the Fibonacci numbers start with an extra 1 at the beginning. Therefore, little f of n is just going to be the n plus first Fibonacci number. So, using this n tiling method, we can now prove several identities regarding Fibonacci numbers.